Welcome to this video lecture on the subject optical and microwave engineering. In this lecture, we are going to discuss about microwave attenuators. So what is the need for microwave attenuators? So when we are transmitting a microwave signal through a waveguide, so when we want to reduce the power of the signal which without disturbing its original waveform, so we can use attenuators. So attenuators can reduce the power of the signal without disturbing or destroying the original waveform. So attenuator is an electronic device that reduces the power of a signal without appreciably distorting its waveform. An attenuator is effectively the opposite of the amplifier. So when an amplifier provides gain, the attenuator provides a loss or gain less than 1. Some of the characteristics of attenuators are they are passive devices made from simple voltage divider networks used to control the amount of microwave power transferred to one point to another point. So they are attenuating the signal by reflecting or absorbing the energy of some dissipative elements. And the attenuation is a function of frequency. And types of attenuators, there are two types, fixed attenuator and variable attenuators. So fixed attenuators provide the attenuation level which cannot be adjusted. So it is a constant attenuation. So they are widely used to match the impedance between different devices in a circuit. And for variable attenuators, as the name given, the variable attenuators offer an adjustable attenuation level, so we can vary the level of power that can be reduced. And fixed attenuators are used to lower the voltage or dissipate power and to improve the impedance matching. So they are commonly used where a fixed amount of power is to be provided. If such a type of attenuator absorbs all the energy entering into it, we call to it waveguide terminator. And this normally consists of a short section of a waveguide with a tapered plug absorbing material at the end. So this tapering is done for providing a gradual transition from the waveguide medium to the absorbing medium, so that it is reducing the reflection occurring at the media interface. So the dielectric used here is the glass, and attenuators are also used to match the impedance by lowering the apparent standing wave ratio. So this is the fixed attenuator structure. Here we have a shorting plate, and then microwave signal is transferred through this waveguide, and some of the power is absorbed by this slab. And performance characteristics of a fixed attenuators are they are input and output impedances and flatness with frequency, average in power handling capability, and temperature dependence. And next type is the variable attenuator. So they provide continuous or stepwise variable attenuation. So for rectangular waveguides, these attenuators can be flap type or vane type. For circular waveguide, their rotary type attenuators are used. So generally we use flap attenuators. So consist of a resistive element or a disc inserted into a longitudinal slot cut along the center of the wider dimension of the guide. So flap is mounted on the hinged arm, allowing it to descend into the center of the waveguide. And movable vane attenuators, so they are rotary type attenuators. The vane position at the center of the guide can be moved laterally from the center, where it provides the maximum attenuation, to the edges where the attenuation is considerably reduced, since electric field lines are always concentrated at the center of the waveguide. And they are having broad range of application in the electronics and telecommunication industry. The movable vane attenuators are used for signal processing, where they play a crucial role in to lower the amplitude of the signal for further processing or measurement without distortion. And impedance matching, they are used in impedance matching to minimize the reflection from a mismatched load, ensuring efficient power transfer and protecting devices from damage. In cases where a signal cloud potentially damage a device due to high power, attenuators are employed to decrease the signal strength to safe level. and we can have a small assessment. So what is the use of an attenuator in a microwave test bench? So generally in the laboratory we use the attenuators to reduce the power of the signal that is flowing through the waveguide, so that we can measure the output power, impedance, and also standing wave ratio at the load. And then what is signal attenuation? So signal attenuation means reduction in the signal level or reduction in the power of a signal.